Hi everyone. Today we're going to learn a little bit about earthquakes. If you should need to get a hold of me, my email address is on the screen. It's rcrawford@jcpsmail.org. So I do want to point out that plate boundaries can be very violent places. And of course, by that I mean tectonic plates. When we look at plate boundaries, we find all sorts of natural disasters there. And so, whenever we have these tectonic plates grinding against one another, there are a lot of very strong forces that are involved. When we talk about force on rock, a force or a pressure, the word that we're going to use is stress. So, we might say that tectonic plates put the rock in the lithosphere or the crust under a lot of stress. Now, when rock is under stress, it really is going to do basically two things. It can either fracture or it can deform. When I say fracture, by fracture, I just mean that the stress is going to cause the rock to break and it's going to be in many pieces. This is normally what happens to shallow, cool rock. Okay. And there are some types of rock that are more brittle, but shallow and cool is normally going to fracture. So rocks can also deform. And when we talk about deformation, that's when the stress is going to change the shape of the rock, but it won't break. You might think of the rock as being pliable or plastic. This is something that's normally going to happen to rocks that are very deep, where it's very hot. And so remember, tectonic plates put a huge amount of stress on rocks. We really have three basic kinds of stress. We have something called compression, something called tension, and something called shear. Compression, as you can see, is going to squeeze the crust together. So when we have a force that is pushing from either side, it's going to squeeze it together. And this is going to make, sometimes it's going to make the rocks fold, or it might make it thicken or pile up. We also have another type of stress called tension. This is sort of the opposite. See, we have arrows pulling away. So tensional stress is going to cause the rock to stretch and get thinner, so it pulls apart. And shear is the last type of stress, and shear stress is going to happen when rock is pushed in opposite directions. And this is going to cause the rock, of course, to deform, to change shape, or to fracture. Two words that I need you to be able to use to understand what's happening with earthquakes. I need you to understand the words elastic and plastic. So elastic, if you see the term elastic for deformation, that means that the rock is going to temporarily bend due to the stress, but it's going to return to its original shape. So this ruler is a good example. So, rock can bend without breaking, much like this ruler is bending. But, once we release the stress, that rock's going to return back to its original position. It's going to snap back into its original shape. Also, things like the stress ball, right? This is elastic. So once the force is no longer applied, it's going to return to its original shape. Plastic deformation, remember we're talking about hot rocks that are usually pretty deep. We're talking about rock that's going to be permanently bent due to stress. And so remember, this is going to happen often deep underground. So what in the world is an earthquake and how does all this relate to it? So an earthquake is really, as you know, just a sudden powerful movement of the rock in Earth's crust. So let's take a look at this diagram. First off, I want you to note that this is a particular place where an earthquake has happened. Okay, so this is we have several things labeled here. We have something called a fault. And this fault is also this diagonal line that goes through here. We have something called a focus. We have something called an epicenter, and something called we have some waves. Okay, so seismic waves. Once we earthquake energy moves by waves or big, huge vibrations. Okay, so an earthquake is really just the rock in Earth's crust vibrating back and forth very powerfully. These earthquakes normally happen along a fault, and a fault is nothing more than a huge crack in the rock of Earth's crust. So, on one side, this is one chunk of rock, and on the other side is another chunk of rock. And we can treat these two things as if they're separate because they can move independent of one another. And so a fault is a really huge crack in Earth's crust, and it travels very deep down through the rock. So when we talk about earthquakes, the focus is the place where the earthquake happens at. This is normally deep underground in the rock. So the focus is going to be the place where we have the rock fracture or slip. And we're going to talk a little bit more about what causes an earthquake here in just a moment. But the focus, that's where the earthquake happens at underground. If we go directly above the focus on the surface of the earth, we're going to have what's called the epicenter. The epicenter is going to be that place on Earth's surface where we're generally going to have a lot of damage. So a fault is just a huge crack in the rock of Earth's crust. It goes pretty deep. The focus is the place where the earthquake happens deep underground, and the epicenter is a place directly above the focus. And the earthquake waves, well, we call them seismic waves, and these are just powerful vibrations. So what causes an earthquake? Okay, so we have rock on both sides of a fault that are moving independently of one another. And if we look, we can see here that this particular fault block is moving this way, and this one is moving in the opposite direction. And you can see that this is putting some pressure and creating some stress on these two rocks, right? And so occasionally we have the rock at these faults that become locked together and they can't move. But the fault block is still trying to move. So pressure begins to build up, stress begins to build up. Eventually, the rock is going to slip suddenly or it's going to fracture and it's going to release all this pressure. So we may have energy that was stored for years and years and years that is released all at one time. And that's what causes an earthquake, like this sudden slip or fracture of rock that has been sort of locked in place and stuck together. And of course, earthquakes going to cause a lot of damage at the surface. So when we talk about this sudden slip, this sudden return of a rock to its original shape, this is something called elastic rebound. Elastic rebound is when a deformed rock is going to return to its original shape, and that rebound, that return to that shape after and releasing of the stress all at one time, that is what causes an earthquake. As you well know, earthquakes can be extremely dangerous, and they can cause a lot of damage. So, if you see, this is a really interesting picture. This is a train track after an earthquake. These train tracks were not laid down like this. They were, of course, laid down in a straight line. But you can see that this is a place where the fault was, and we had a sudden movement on either side that changed. So this track went, so this part of the rock went this way, and this side of the fault went this way, and you can see where the fault has happened. You know, you with some earthquakes, you get like incredible damage at the surface. You can see that this roadway has been completely destroyed, just like I believe this was an earthquake in Mexico City. These buildings were just utterly devastated. Earthquakes can cause a huge amount of damage when that stress in rock is released all at one time. It's amazing. So how often do earthquakes happen? Well, it depends. Really, across the globe, we have thousands of minor earthquakes every day. Most of these that are 2.9 magnitude or less, we can't even feel them. A moderate earthquake, and we've had some moderate earthquakes about this size here in North Carolina. You're going to have worldwide about 800 of those a year. Now, a big earthquake, a massive earthquake, is going to be 7 to 7.9 in a typical year. This is a very destructive earthquake. We're going to have in the teens. We're going to have somewhere around 18 seems to be our average. And once a year, we're going to have one earthquake that is just utterly devastating. An 8.0 magnitude is really a destructive earthquake. So let's see if we can get a look at what we have here and see if I can help you understand. So of course this is a world map, and every one of these little pink dots represents the place that an earthquake has happened, and this shows earthquakes with a magnitude of 4.0 or better between 1960 and the year 2000. Now, what is interesting about this, guys, is if you might remember when we looked at the map of the tectonic plate boundaries, And one of the things that I said about the plates is that the interior of the plates are usually going to be pretty quiet, but around the plate edges, we're going to find that we have a lot of activity, a lot of violent activity. So you can almost see that these earthquakes are happening right where the boundaries for these plates are. So plate boundaries where two or more plates grind together, we have a lot of earthquakes. In the middle of the plates where we are far from those plate edges, we're not going to have as many earthquakes. Of course, when we look here, this is here we have North America, and the United States is this part of North America. And right through here, we have the state of California. Some of you may already be aware that California is a place that gets a lot more earthquakes, and some of them are quite powerful. California gets these earthquakes because they are right on a tectonic plate boundary, right where two plates come together. So over here we have the Pacific plate, and over here we have the North American plate, and these two plates are grinding past each other. And as they do, sometimes the rock between these plates gets hung up, and stress builds up in the rock. And this can happen for years and years until that stress is released all at one time. This one very famous fault in California is something called the San Andreas Fault. And so this is the source of a lot of earthquakes, really, that are anywhere from San Francisco all the way down to Los Angeles, which were these huge population areas. The San Andreas Fault is really quite incredible. If you ever visit California, you ever live there, I would recommend you go look at some places where the fault runs through. This is a picture taken from an airplane, and you can actually see how that fault has changed the surface of the earth, changed the surface of the land. Guys, that really about does it for today. I hope you have a great day. We'll learn about volcanoes soon.